Yeah, hello. Now let us look at using ggplot2 package for bivariate data visualization in R. Okay. Yeah, so what we are going to do is similar to what we've actually done before. I have the code available, so you can actually have the code and you can copy the code all the way from you can copy the bivariate visualization code for ggplot2, and then you can actually follow along by copying and pasting and learning along. Okay. Now, if you actually follow the first presentation on using ggplot2 for visualization, we actually did that of the univariate visualization. And these were different univariate plots in which we actually created. But we have the histogram, we have the boxplot, we have the dot plot, we have the bar chart, we have the bar chart, which is the flipped, which is horizontal one. We have the pie chart for categorical variable. We have the tree map, which is also similar to the pie chart. And then, so we have the line plot, which for a single variable plotted against its index, okay? So these were the different univariate plot. And univariate means just having a single variable and you wanting to display a distribution of that variable to better understand, the variable, okay? Now, let us look at bivariate visualization, where you have two plots and you would want to plot these two plots, where you have two variables and you would want to actually plot the variables against each other, okay? So let me clear this visualization. So again, we are still going to make use of our hints data, okay? So first of all, as usual, you have to be able to upload the data set, which we are using the hints data, which is made available to you. So once you have uploaded this data, you are able to now go ahead and then we can look at the names of the data. We can actually attach the data so that, again, if you attach the data, it prevents us from actually continuously using a $sign after the data to call a particular variable, okay? So we just attach it. Once you have attached it, we are able to read the variable directly, okay, or call the variables. We can get the statistical summary. Again, there are negatives here, so we have to clean the data, okay? So we are using this line of the code, okay, this line of the code to be able to clean our data by removing. So we are cleaning the data for quality of care, health insurance, age, gender, full-time occupation, BMI, smoking status, moderate exercise, and then drinking per week, okay? Alcohol drinking per week. So we are eliminating all the negatives within those variables, okay? And so then we are creating a new data. And so we are naming that data, hence data underscore new. And then with our original data, we go into that data using the square bracket. And then we use the concatenate function to create a vector of all the variables we would want to clean. And then within each of the variables separated by n, okay? And then we need data of that variable greater than 0. And then thereafter we bring comma that, okay, give us every single column of the data thereafter, okay? So now we can go ahead and run this line of the code. Now, once we've run it, we can actually look at the head again. It's still the same thing. We have the same head as before, which is for our new data. And then we have to attach our new data to ensure that now R is able to recognize the new data and not override the old data, so that whenever we are calling the variable, R is making use of the variable within the new data, not the old data. So let's attach the new data. And then now we can go ahead and then use the summary. And so you can see those variables which we cleaned, those variables now do not have negatives anymore. So we can proceed to actually perform further analysis, okay? So for instance, we actually want to create, if you take the quality of care, if you run the summary of the factor. So factor means making sure I recognize that variable as a categorical variable, okay? So we want the summary of that variable alone, but we want the summary of the factor of that variable. Now, so you can see initially when we didn't use the summary of the factor of quality of care, you can see I recognize it as if it's a continuous variable, right? But now we use the factor function within the summary function. Now R is able to recognize it as a categorical variable, and now it's able to tell us the count or the frequency for each of the levels of that categorical variable. But then now if we plot this, it will be so hard to read. What does 1 represent? What does 2 represent? What does 3 represent? What does 4 represent? And what does 5 represent? Now, in order to ensure that we actually give it a name which is readable, okay, and easy to communicate, we actually want to create a new variable within our this hence new data, okay? So within the hence new data, we are going to create a new variable which we are going to call quality of care underscore new. And then using the square bracket, okay, we are going to go into the data we clean and then pull out quality of care. And then what we are saying is for every quality of care equal 1. Now remember in R, once you use double equal sign, it means strictly equal sign. For every quality of care equal 1, assign it to what? Excellent. Now the same thing for when it's equals to 2, you assign it to very good, and equal to 3, good, and then all the way to poor. So we can highlight the entire code and then we can run it. Then we can actually see the head of this particular data to see whether it is reflected in the new variable is reflected. And here the new variable, which is now showing quality of care new. And now it is showing with the names of each of the levels, right? Rather than showing it in values. Okay, so now we have to reattach that particular variable, okay? So that now once we attach it, we can actually go ahead and then be able to, let's say, perform we can find the summary of the factor of what quality of care new. So this particular variable, and now we can run it. So here is it. Okay. So now rather than giving us in this form, which is not very readable, now we have it in this form, which clearly is readable, right? Okay. So now next, let us now proceed to perform our visualization for the bivariate for 2 variable, which is the bivariate visualization. We want to start with, bar chart, okay? So we would want to perform a bar plot of quality of care along with what? For BMI, okay? So in other words, we actually want to know the distribution of the quality of care for BMI. So in other, if you take somebody with excellent health status, what is their distribution for BMI, and then the same for fair, good, very good, and good, okay? So again, using the ggplot function, we put in our data, and then using the aesthetic function, the variable in which we want to look at the bar plot is what? The quality of care. And then we want to actually plot it against the BMI level. So we want the BMI to be at the y-axis and the quality of care to be at the x-axis. And then we want you to fill it with what? The quality of care, okay? That gives us each of the levels of the quality of care. And then geom bar, we want the start equal identity, okay, which allows us to be able to, have a better reading of the bar plot. And then we have the tune to be what? Tune underscore minima to give us a different kind of tune we want to observe. So let's run it. So there's what we observe right here. So you can see, and you can always use the zoom to actually zoom the plot, and then you can actually observe it very well. So you can see that now we can actually read and tell which of the quality of care has the highest, BMI level, right? So you can actually see that in terms of, we have those with very good happen to have the highest observation of the number of BMI within the data set, okay? Followed by those with, excellent, good, and fair, and then poor, okay? So basically, it's just telling us that how does the distribution of the individual quality of care looks like for BMI, okay? So we can close it, and then now we can go ahead, and then next, let us look at plotting a scatter plot, okay? Coming up with a scatter plot. So with a scatter plot, of course, scatter plot, you need two variables, which is one variable on the x-axis, another variable on the y-axis. And you have to be able to understand which variable represents the dependent variable and then the independent variable, okay? So remember, it is the dependent variable is always explained by the independent variable, okay? In other words, the dependent variable depends on the independent variable, right? So the independent variable is always the x variable. So before you plot a scatter plot, you have to be able to know what is my x variable, what is my y variable. So in other words, so over here, for instance, we have exercise and then we have BMI, right? So you can say that intuitively, you can say that exercise can predict someone's BMI level. So in other words, BMI has to be the dependent variable depending on exercise. So maybe in real life, you can say the more somebody exercise, the less their BMI level, and the less they exercise, the more their BMI level, right? So in other words, BMI depend on exercise. So exercise have to be the X variable. So now we use the ggplot. We call our data, and then we use the aesthetic to put in our variables, which is the Y and then the X variable separated by a comma, okay? And then now we use the geom points, which is actually allow us to see the points of the scatter plot, okay? Plus, we have the geom suit, which is actually going to allow us to observe the regression line, okay, after plotting the scatter plot of exercise versus BMI. And then also we have the GJ title to give the title of our plot, which is, we can say the relationship between BMI and exercise and BMI, or BMI and exercise. Okay, that would have been this much suitable title. But over here, we are saying scatter plot of what? Exercise, weekly minute moderate exercise versus what? BMI. And then our x-axis, of course, is representing the exercise variable, and our y label, of course, or y-axis is representing the what? The BMI level, okay? So now we can go ahead, highlight all of them, and then we can run it. Okay, so now you can see this is the BMI level, and then you can see that, basically, there seems to be some kind of negative relationship between BMI and exercise. And if there's a negative relationship, you might be thinking that, okay, maybe the more somebody exercise, the less their BMI level, and then the less they exercise, the more their BMI level. Okay, but this is a very weak relationship you might think of. Then also, next we can also project box plot. Okay, we can display a box plot, and we can display a box plot of BMI by the quality of care status. So in other words, for each level of the quality of care, we'll be able to understand what is the distribution of their BMI level. So if you take excellent care, very good, good, fair, poor, what is the distribution individually for those levels of quality of care in terms of the BMI? So again, we use the ggplot. We have our data. Now the aesthetic we are looking at, we want our x-axis to represent the quality of care because we want the box plots to be vertical, and then we have displaying the y-axis should be the BMI level, okay? And then again, you should be able to better understand even if you are displaying the distribution of BMI for each quality of care. Now you better understand how much each quality of care gives you in terms of the distribution of the BMI. So now we are going to use the geom box plot to be able to get our box plot, and then the aesthetic, which is fill, okay, equal the factor. Now fill, now we use the factor for R to be able to understand that, okay, for each of the level, the quality of care underscore new is representing a categorical variable. Okay, and that's how R is able to now divide them into different distribution of the BMI. Okay. So so right here is where we are able to generate our box plot by each of the quality of care box plots for the BMI. Now the labs. So labs here, we have the title, and then we have the Y as its name, is the X as its name, and then we have the Y as its name. So the Y is representing the BMI level, the X is representing the quality of care, and our title is what? Maybe we can see the distribution of BMI by quality of care, but we just for the demonstration, we said box plot of BMI by quality of care. Again, it's always good to give a suitable name. So we can put the cursor here on the first line and then just run it. Okay, so it gives us a very beautiful plot now showing the distribution of BMI by each of the levels of quality of care. Okay, so right here you are able to even understand which of the quality of care had the highest median BMI. Okay, now basically we can see that those with very good have the highest median BMI, and then for each of them we are having somewhat outliers, and those with very good quality of care happen to even have more outlier. Okay, yeah. So there's how you can actually, read the table to better understand. And then you can see those with poor health status, they happen to have pretty kind of a rice skew distribution, okay? And then the rest seems to be fairly normal with some outliers in terms of their level of BMI. Okay, now when we say fairly normal, it means that, you have the median, which is the line in between the box, dividing the first and then the third quarter almost pretty equally. And that is why you think about maybe it's kind of fairly normal distribution. Okay, so now let us also generate an area plot. So we are going to generate an area plot of age by gender, okay? So to generate an area plot, everything else, so we have, again, using the ggplot function, we have our data, and then we are going to generate an area plot of what? Of age, okay? And then plus, we are going to have geom area, and then we are going to be able to fill it with what? Gender. And that allows us to be able to know that, oh, okay, within the plot, we are actually having the distribution. We are able to understand the distribution of age by, gender, okay, within the area plot. And then we have the star equal bin, which actually give us add additional information on how the plot should look like, and alpha equal 0.6, okay? And then we have plus our labs, where now you are actually able to give it the title of your plot, which is the area plot. So we say area plot of what? Age by gender. We could have said the distribution of age by gender. And then also the y-axis represent the count. So let us run it. So now we are able to understand the area plot. So 1 is representing male and then 2 is representing female. But again, before you generate this area plot, for you to have a much better reading of the plot, you have to ensure that you recode a new variable of gender to ensure you have 1 and 2 as male and female to display instead of 1 and 2, okay? So next, we can also have a density histogram distribution of age by gender. So to have the density histogram, you just use what is called the geodensity. In place of the geo area, you put the geodensity. And then with that, we don't need the star. We don't need the star and then the alpha. Okay, we can actually ignore them. But we need a fill, and the fill within the aesthetic function actually allow us to be able to display it by that categorical variable. Okay, the levels of the categorical variable. And again, we have our labs, which we're able to put in our title and then our y-axis. So the title, the distribution, the density histogram distribution of gender by age by gender, and then we have the y-axis being what? Density. So let's highlight it and then let's run and see. So there's how we have. So now, instead of having it in this form, which is given it by count, now we are having it more in what? In a density, which is pretty much, it reads the same, but instead of this one is the area function, area graph, and this one is representing the what? The density histogram distribution. Now, we can also have, we can also include a more advanced plot for the ggplot, where we have several different kind of densities for different levels of a particular categorical variable, okay? So in order to do that, we are going to, of course, you might have already load the plot, ggplot2. One, how do you call it, package in which you need to load it is called the ggRich package, okay? That's what you have to load the package. Once you load the package, now it allows you to be able to plot, display a plot for each of the levels of quality of care. So what we are going to actually do is we are actually going to display the distribution for quantitative variable for several groups, okay? So in other words, we are displaying the distribution of BMI for several groups of what? Of the quality of care, okay? So again, on ggplot, we have our data, we have the aesthetic, which allow us to be able to input our variables. So the X variable is the BMI, and then the Y variable is going to be the quality of care. And we are going to have fill to be what? The quality of care, which we, the quality of care underscore new, okay? And then we are going to have the geom underscore density underscore regis, which actually allow us to be able to have that kind of multiple distribution for the quality of care. And then also we have tune, which is actually allowing us to be able to get a different style of tune. So the tune, we put in nothing, but if you can decide to add some information within the tune. And then we have the labs. Again, we have the title, which is a distribution of BMI by quality of care. And then we have BMI, our x-axis being BMI, our y-axis being the quality of what? Quality of care. And then over here, the tune. So in terms of the tune underscore regis, we have nothing. In terms of also the tune, which is legend position, we are not also putting in any information in there. But this right there allow us to be able to visualize how the outlook of the different distributions of quality of care for BMI. Okay, so we can just put the cursor on the first line and run it, or highlight on everything to the end and then run it. Okay, so now you can zoom it, and then you'll be able to actually better understand. So there's what we have here, right here, which is actually giving us what? The difference. So there's the distribution for very good, poor, good, fair, and then what? Excellent, in terms of the distribution of BMI for each of those groups. So it means if you have a multiple group, you actually be able to observe. Now, we can also have what is called a time plot, okay? The time series plot, which actually allow us to be able to observe trend over time, okay? So we are actually, for you to be able to use a time series plot, you actually need the time, which could be the date, either in months or in years, okay? So we are going to use a built-in data in R, which is produced by ggplot2 package. So that data is what? The economics data. So we say data, we are using the data function, we get the economics data from using from this package, which is the ggplot2. And then let's run it. So we can look at the head of the data set. So we have the date, and then we have different other variables, which is unemployment variables and different other variables. And we have the dimension of the data, which is, we have 574 observation and then 6 columns, okay? Then now from here, we are able to perform our time series plot. So we have the ggplot of economics, okay, which now is the data set plus geom okay? So we could have used this on a different line, on a second line. So plus the geom of what? Our aesthetic, which is date. Within the aesthetic function, we have x equal date, y equal, we are plotting it with this particular variable, which is the PCE. And then the color equal what? The color equal the levels of the PCE, okay? And then we have also, we are using this particular color, which is the PCS. And then we have the lab. Again, the lab allows us to be able to put in a title, which we said the economics time series of prices, okay? So the PCE is representing the prices. So it's like we want to observe the prices over time, okay? Now let's run. So this is how we are able to now observe. So this is actually giving us the prices over time. Now we could have actually added our X lab, and then change it, instead of piece CE, we could have actually changed it to what? Price, okay? So by just putting the comma, and then we can say that X is equals to what? We could have just added price. And then you can run it, and that allow us to be able to get that distribution. Okay. So this one's x-axis. So, oops, the x-axis is dates, and then the y-axis is price. Y equal price. Okay, so we can now run it, and now we have it. Okay, so you have the date, and then the date in years. You can even also say date in years. Okay, so there's the different plot we can actually, different bivariate distribution plot we can actually have using ggplot, okay? So I will see you in the next lecture for a more also advanced plotting, which is going to be multivariate plot. Okay, so see you.